In this video we're going to complete example 2, which is all about an angle of depression. And in this example we have Hugh, who's standing on a cliff that is 67 meters above sea level. So I'm just going to get right into it and start drawing it. Here's my cliff and here's Hugh standing at the top of it. And the cliff is 67 meters high above sea level. He is looking at a boat that is 1.2 kilometers from the base of the cliff. So I've got my ocean down here, and if I travel out 1.2 kilometers, I get my boat. Alright, so I'm just going to draw a little sailboat. That's my boat out there. It's asking us to calculate the angle of depression of the boat from the cliff to the nearest minute. Alright, so what we need to do here is we really need to make a triangle. That's our first step. Focus on the triangle first. And I see if I draw a straight line from the top of the cliff, and it's quite hard for me to do it on a writing pad, so I'm going to make my best effort. So we're going to go from the cliff to the boat. Oh, I'm quite proud of myself there. There we go. Alright, now we can see we've got a triangle, and it is a right angled triangle, which is great. And we've got two of the sides marked. What are we trying to find here though? It wants us to find the angle of depression. And this can throw people a little bit, because the angle of depression, you've got to draw a straight horizontal line at the top, a dotted line, and the angle of depression always comes down from there. So we're trying to find theta here. And what can throw people is they look at that and go, well, how can we find theta? Theta is actually outside of the triangle, and I need something inside the triangle. And I'm going to let you know that theta up here is exactly the same as the angle inside the triangle down near the boat. In fact, what you'll notice is the angle of depression is exactly the same size as the angle of elevation. So when you solve these angle of depression questions, you can usually get them correct if you just treat it the same way you would an angle of elevation question. Anyway, we've now constructed our triangle and we can focus on solving the problem. I'm going to label my sides. My hypotenuse is up here. Opposite theta is the 67 meters and adjacent is the 1.2 kilometers. I don't need the hypotenuse, I just need the O and the A. There's another thing I'm going to do. I'm going to say that I know it's 1.2 kilometers, but I want to convert it into meters, 1,200 meters, because it's really important that both units are the same. They're both in meters, or I could have made them both in kilometers. I'm going to write down my acronym, SO, CAR, TOA, and I can see that I've got an opposite and adjacent. So I'm using the TOA section, the last part of my acronym here. T stands for tan, my angle is theta, equals, and my vinculum bar. After tan comes O, then A. So O is 67, that goes at the top, A is last, 1200 at the bottom of the fraction. And at this stage we're going to do the invert, meaning we're going to bring the tan to the other side with the -1, meaning inverse tan. And in brackets 67 over 1200. Very important to put this fraction in brackets. Otherwise you can make a fatal error. Alright. Now, to get tan inverse, we're going to go second function tan on this calculator. I'm going to open up the brackets. And I can write it as a fraction, but I prefer to just go 67 divide 1200. Only because divide and fractions work the same, like so, equals, and I get a little over 3 degrees. Now I just need to check the question. It wants it to the nearest minute. So on this particular calculator I'm going to go second function DMS, and here I've got 3 degrees 11 minutes, but just looking at the seconds are above 30, which means I need to round this up, 3 degrees and 12 minutes. 3 degrees 12 minutes, and that is the solution for this particular question, and that concludes example 2.